This program is going to explore formal charge. To begin, let's consider some Lewis structures for carbon dioxide. How many electrons do we have in the diagram? Carbon gives 4, and the two oxygens at 6 apiece give us 16 electrons, or 8 pairs. We begin with the skeletal structure with the oxygen-carbon-oxygen combination and place our first electrons between the carbons and the oxygens. Complete the octets on the periphery. We notice that the carbon in the middle is not satisfied, doesn't have its 8 electrons, so we move a pair in from the oxygen on the left and another pair in from the oxygen on the right. And that gives this characteristic structure for carbon dioxide. But I want to consider another way of doing this. Again, I'll begin with the skeletal structure, completing the octets of the species on the outside. The carbon in the middle is not satisfied, so I'm going to move a pair in. But instead of getting a second pair from the other oxygen, I'm going to move in another pair from the original oxygen. This creates this arrangement. It's no violation in the Lewis structure. Everybody has 8. But the structure now looks like this. Why is it we prefer to draw the first one? Formal charge is our way of answering this problem. Formal charge assumes all the atoms have the same electronegativity. That means they share electrons equally in a bond. The formula to calculate formal charge is determined by taking the number of valence electrons, subtracting the non-bonded pairs of electrons, and 1/2 of the electrons involved in bonds. Let's look at figuring out the formal charges of carbon and oxygen in these two models. In my first model, the oxygen on the far left end has 6 valence electrons. 4 of them aren't bonded. Minus 1/2 of the electrons involved in the double bond gives me a formal charge of 0. This would also be the same for the oxygen on the other end. The carbon in the center has 4 valence electrons. It has no non-bonded pairs of electrons, but the number of bonded electrons are 8, and so I use 1/2 of 8, and it also gives me a formal charge of 0. So all the species here have formal charges of 0. In this particular model, my first oxygen, 6 valence electrons, minus 6 unbonded, minus 1/2 of the ones in the bonded pair, gives me -1. The central carbon is back to 0, and the oxygen on the right-hand end with 6 valence electrons, minus the 2, minus 1/2 of the 6 that are involved in the bond, gives me a +1 formal charge. The general rule is the preferred structure is the one with the lowest formal charges. Hence, we can see this model fits. I want to look at the second point in the preferred structure in my next diagram. Consider dinitrogen oxide. It has 8 pairs of electrons. We can now go ahead and draw some possible structures that fit this. And here are 3 possible structures. I want to determine now the formal charges of nitrogen and oxygen in each of these molecules. I won't go through each one individually, but just give them to you. So again, the one with the lowest formal charges is preferred. Well, in this case, my top 2 models both have similar formal charges, but the lower one I can clearly eliminate. Now what do I do to determine which of the top 2 models is the correct one? Here's where the second point comes in. The more electronegative element possesses the negative charge. Oxygen, right beside fluorine in the periodic table, is the more electronegative element, so it's preferred that it have the negative charge as opposed to the nitrogen. Hence, this model is my preferred structure. Let's try a question dealing with formal charge. Below are 2 Lewis diagrams for sulfur dioxide. The first has a central sulfur with a stable octet. The second has a sulfur with an expanded octet. Which is the preferred arrangement? First, we'll check that we have the number of electrons correct. There should be 9 pair in both diagrams. And I'm going to use the calculation of formal charge to determine which is the better one. So here we can go through. The first oxygen has a 0 formal charge. The sulfur in the center, +1, and the oxygen on the right-hand end, -1. If we now apply formal charges to the second model, our first oxygen and the one on the end both have charges of 0. The central sulfur is also 0. So that's my preferred structure. It's worthwhile noting that these two models have different bond orders. The first one, due to resonance, has a bond order of 1.5, and the second one has a bond order of 2. They both have 3 electron regions about the central sulfur. As a result, they both would have the same shape, with 3 regions, 2 of them bonded, 1 not. Both would be bent molecules. Remember, questions are always welcome, and thanks for watching.